14 is where our notes start. When you look at this project, each one of these cards is going to be worth 5 points. And then putting the right arrows in the right spot is going to be, when you finish this to turn in tomorrow, is going to be each of those arrows is worth a point. If you look at the notes for F4, you can kind of see how they are set up. I will tell you that 4 of these will be the same solution. 4 will be the same solution. I'm not going to tell you what that solution is, but that is my hint to you. There will be 4 of them that have the same X and Y, okay, when you are looking at it. You will have 2 of these solutions here that are going to be decimal or fraction. So it could be the X is a decimal or the Y is, but you're going to have 2 decimal ones. Most of you found when you were working on C6 that you got these answers to be decimals. They're going to be decimals. There was another one here in C5 where you might have some decimals. So it's not wrong, okay? By the end of the period, looking at your F4 notes, that's what is due when you turn it algebraically. It says, which students solved this correctly using these 2 equations? So the first one says x is equal to negative y plus 5, and the second equation. So notice the first person replaced the x in student 1. They replaced the x, if we are looking at that problem, with negative y plus 5 plus 3y. They had negative 2y plus 5 equals 3y equals 12. They added the like terms. Negative 2y plus y gives us y plus 5 equals 12. They subtracted 5 and got 7. Student 2 solved it and put it in a parenthesis. Same thing, y minus 5. They got 2y plus 10 plus 3y equals 12. Y added our like terms. Y plus 10 equals 12. And then y equals 2. Which one did it correctly? Student 1 or student 2? Take your foot down. Take it down. Right. Thank you. So which one of these did that correctly? Thank you. We're on our notes, page 13. Which one did it right? 1 or 2? 2. 2 did it correctly if we are looking at it, because when you substitute in, anytime you substitute, you want to put that in a parenthesis, and you have to make sure you distribute. So you get y equals 2 versus 7, and then you plug in this first equation where it was x equal y plus 5, and it was a negative y. That's how they got negative 2, because it was a negative in front of the y. So negative 2 plus 5, and x was 3. Our ordered pair is 3, 2. And it should check in both of them. As you look at the bottom of page 13, it says systems are not always written the way we want them to be written. Sometimes we have to rewrite them. So it says when you pick whether or not to solve for the x or the y, a general suggestion would be to solve for the variable that has a positive 1. When you look at these 2 equations, which variables have positive 1 in front of them? One of them, would it be what, Caitlin? Which one has a positive 1 in front of it? The second one. Which variable?
The y.
The y does, as does the x, right? So both x and y have a 1 in front of them. Which one do you want to solve for, Rajad? The y. Okay? Now, my suggestion might be, or else take it out, for the x. And so in this equation, I want to get the x by itself. If I'm getting the x by itself, Nolan, what do I have to do with this y to get the x by itself? Subtract it. So we're going to subtract y from both sides. So I have x equal, Luden, to, I could have negative y minus 14. Can I write it as 14 minus y? That works also. So now I'm looking at my equation, and Rowan, instead of the x, we're going to put that in a parenthesis. So we're going to put 3. We're going to go back here. Take your hood down, please, and leave it down. As we are looking at that, we are going to put 3. And Rowan, what did we just say x was equal to?
X is equal to 14 minus y.
So we're going to put 3 times 14 minus y. Then we're going to continue with that equation. And Abby, the rest of that first equation is what? So minus y equals 30, okay? we are going to continue as we are doing that. So if I am continuing, Bashir, using my distributive property, I'm going to have what? Using our distributive property, 42 minus 3y minus y equals 30, as I looked at that, okay? There's calculators up in front if you need one. Next thing we are taking a look at in this problem is we are going to now, Jordan, subtract negative 3y. We have a negative 3y and a negative y. Those are my like terms on the same side of the equal sign. So 42 minus what? What are our like terms going to be? Sure. I can put a negative 4y. Do some of you like to put plus a negative? Would it matter? So I either negative 4y equals 30, or you could have plus a negative, right? As I'm looking at that. Ashley, next step in solving for y. Subtract 42. When I subtract 42 from both sides of my equal sign, Cameron, I'm going to have. Okay. So as I'm solving that one, Kendall, I'm going to divide by both sides by negative 4. So I'm dividing both sides by negative 4. Go to the office. Y is equal to 3. Yeah. The notes are online. Take your computer with you. You can do it up there. Tell them I'll send it. Our original equations, do you think is easier to find x? The top one. So we're going to go with 3x minus y equals 30. I personally think the second one's a little easier, but we're going to go with yours. So we're going to put 3x, right, minus 3 equals 30. So if I'm solving that, Levi, and I need to get 3x by itself, I'd now do what? Add 3 to 30. I get 3x equals 33. And math, if I'm solving, I'm going to divide both sides by 3 and get 11. So my answer was 11, 3. My x is 11. My y is 3. I'm going to check it. Which equation do I have to check it in? The second equation. Why? Because I used the first one. So if I put in the second equation, I had x plus y equals 14. Does it check that 11 plus 3, x plus y will equal 14? Yeah. And so I might not even quite write it down, but 11 plus 3 is my x plus y, and that does equal 14. It checks. I went to the second equation and plugged that in. Okay? On the top of the next page. Again, we do not have one variable by itself. So Sam, I need to get one of the variables that has a 1 in front of it. So I look at all my variables, and I have 3y and 4x, definitely not there. So in the second equation, which variable has a positive 1 in front of it? Y. So I want to get what y is equal to. So if I'm doing that, Aaron, and I want to get y by itself, what do I have to do to get rid of this minus 2x, or plus a negative 2x? I'm going to add 2x. I'm going to do that on both sides. And when I rewrite that, it's okay if you put it as y equals, you can put the 2x minus 3, or you could have wrote it as y equals negative 3 plus 2x. Remember, these are exactly the same. It's just that one is written with the x first and the other one not. So, Dan, we now want to substitute into our first equation. So we're going to write our first equation. So when you do these, it takes a little bit of work. So 3, and then what, Dan? Okay, so 3y plus 4x. Okay, so we didn't substitute anything yet, right? And what we now know is that y equals one of these two things, right? So which one do you want to use, the first or the second? Okay, so tell me what to write.
3 2x minus 3 plus 4x.
Okay, make sure you write that down, please. So now we are distributing. So as I do the distributing, Joe, I'm going to have what? 6x?
because that's minus 9. I'm taking 3 times both those. Plus 4x is equal to 14. Patrick, I'm adding my like terms because they're on the same side of the equal sign. So when I add those like terms, what am I ending up with? 10x. And I have minus 9 equals 14. Abby, I want to get the 10x by itself. What am I doing? Adding 9. So when I add 9 to both sides, Laura, I'm ending up with 10x is equal to if I'm looking at it, Cameron, sorry. 10x equals 20. So if I added 10, I'd get 24, right? So I'm adding 9, so I get 23. So we're going to get a weird decimal, right? And this is why graphing is not always good. So when we divide both sides, Kendall, we're going to divide both sides by 10. Let's get our decimal answer. X equals. So you will start getting decimals and fractions tonight in your homework. X is going to be equal to, in this case, what did we get, Kendall? 2.3. So some of you might be thinking, oh my gosh, I did it wrong. I got a decimal, I got a fraction. No. We're going to go to this second equation, which was negative 2x plus y equals negative 3. And we are going to take negative 2, but instead of x, we just found x was 2.3 plus y equals negative 3. Please write that down if you have it. When you take negative 2 times 2.3, you get a negative 4.6 plus y equals negative 3. We're going to add 4.6 to both sides, and we get y. 4.6 minus 3 is 1.6. That's my y value. And instead of leaving our answer just like this with an x and a y, ordered pair. 2.3 comma 1.6. Okay. The story problem that's here, we're going to be coming up to doing a lot of story problems soon when we do the review for this. And in tonight's homework, it's just equations. So I'm going to have you turn to the top of page 15. We'll come back to that one on 14 when we get to our story problems, and possibly a little next week. But I want you to look at this page right here. And we are going to do the second one because it's a little uglier. And I just want you to see what happens. Okay, and then we're going to get you started in your homework. So when you look at the notes, I did do all of these on the notes online, but on this one, I'm just going to kind of finish and we're going to solve here for x. If I'm solving for x in this one, what should I do, Aaron, to get x by itself in that second equation? And which would give me a negative 7 what? Minus 3y. Okay? So now as I'm looking at that, Sam, I now know this is what x is equal to. And what I might want to kind of do is go back to my first equation and go, oh, that's what I'm going to replace the x with. Okay? So Sam, tell me in that first equation, I'm going to rewrite it as 6y plus what?
Plus 5, parentheses, negative 7 minus 3y.
And this is where some of you sometimes, and then equal 8. So everything stays the same in that first line, except where the x was and we replace it. Some of you, sometimes when you distribute those negatives, it's better to put plus a negative. But we're going to get 6y plus negative 35 minus or plus a negative 15y equals 8. Now the reason I like to change subtraction to plus a negative is that when I add these like terms and they're on the same side of the equal sign, I'm adding 6 and negative 15. And if I am doing that, Riley, 6 plus negative 15y is going to leave me with negative 9y. I still have that plus negative 35 or minus 35 equals 8, which Levi, I'm now going to do what? I'm going to add 35 on both sides to the 8. And Aaron, when we added those, or Bashir, when we added those, you writing, please? You writing with us? Yeah, good. So
What'd you end up with? 42. So we get negative 9x, negative 9y is equal to 42, 43? 43. So, is this going to turn out nice? No. Divide both sides by negative 9. And our y value, when we take 43 divided by negative 9, what do we end up with?
Negative 4, 2 over 9.
Negative what?
Negative 4, 2 over 9.
So when I just put that in as a decimal, did most of you get a decimal, right? We got 43 divided by 9, and it's negative 4.7 repeating. Negative 4.7 repeating, okay? So my y value is negative 4.7 repeating. Does it matter which equation you go back to solve for the x? You just have to pick one of them. If I go to the second one, as I look at that second equation, x plus 3y equals negative 7, I'm going to have x plus 3 times negative 4.7 repeating equals negative 7. So on my calculator, I already have that negative 4.7, okay, and ours should have been negative 4.7, and I'm just now going to take it times 3. Don't erase it from your calculator, just take it times 3. So you get negative 14.3 repeating. So I have x plus negative 14.3 repeating is equal to negative 7. And I am adding that to both sides of the equation. So that when I'm looking at my solution and I add that, I should get 7.3 repeating. And when we go to check our answers, you're going to be able to check them in the back. You're going to be able to check them as you look at the problem. But when we are checking these, they put, instead of 4.7 repeating, they put 4.8. I'd be good with either one of those, 4.7 repeating or negative 4.8 if we round it. I think if you round it to 4.8, then this comes out to be 7.4. I would be okay with either one of these answers. I would take 7.3 repeating instead and negative 4.7 repeating also for your answers, okay? So in your homework, you will definitely need notebook paper. What you're going to see is that the problems, each one on this side, the first 6, their answers will be here. And on the second side, notice you get a lot more fractions and decimals, right? Don't change it to a decimal. Keep it as a fraction, like a half or 4/3 or 5/2, as you are looking at those. So when you do the problems, what you're going to find as you do those is that you're going to have more of those fractional answers.